So the next special parallelogram I want to talk about is a rhombus. Now, rhombi is how you say that plural. Let me show you a Venn diagram real quick. If this whole, let me move that out of the way. So if this rectangle here is my Venn diagram, and then this represents all the parallelograms, I have a couple subsets, meaning more special parallelograms. So this right here, rhombi, is just plural for rhombus. I wanted you to see that word. A rhombus is a parallelogram. See how it's all inside parallelograms? So remember we talked about that in Unit 2. So all rhombis are parallelograms. So if you're a rhombus, then you're a parallelogram. So what does that mean? Well, it means that when you know something is a rhombus, you actually know that all these things up here, all the properties of the parallelogram, are going to be true. But in addition, you're going to have some more tools here to use for a rhombus. Okay, so the definition, this first one, again, people think of a diamond. They often call it a diamond, but it's a rhombus. So a diamond or a rhombus is when all four sides are congruent. Remember, congruent means equal. So in a picture, you know, traditionally this is what people would draw if you said, hey, draw me a rhombus. But really, all it means is all four sides are equal. So even if I drew what looks like a square, if I'm only putting four equal sides, I'm talking about a rhombus. Okay, so what else is special about the rhombus? We've got diagonals are perpendicular. Okay, so if you forgot what perpendicular means, if I draw the two diagonals, so here's one diagonal, here's another diagonal, perpendicular means that they intersect at 90 degrees. Okay, and then the last thing is that a rhombus, the diagonals, okay, so they don't just bisect each other, which they do for all parallelograms, but they even bisect the angles. So what does that mean? That means if I draw a diagonal right here, it's going to cut that angle in half, so this will be the same as this, and it's going to cut this one in half. And because remember, opposite angles were congruent in the parallelogram, so that means all these little pieces are going to be the same. Okay? When I draw the other diagonal, same thing happens. Okay, and since those two angles are the same, I'm going to use 2 marks for every one. Okay, so if this whole angle here was 80, each one of these would be 40. That's what it means to bisect, cut into 2 equal pieces. Okay, so let's look at a problem solving one together. Let's go to page 3. So on page 3, this says that rhombus ABCD has diagonals that measure 10 inches and 24 inches. It doesn't tell me which is which, but this one looks shorter, so I'm going to go ahead and call that one 10. Now, putting this whole thing as 10, okay, this is a technique that I use pretty much for every parallelogram. Putting that information is really tricky in the picture. But remember, if I know it's a rhombus, I know that it's, because the rhombus is completely inside of parallelograms, it's a subset of parallelograms. So I know that the diagonals are going to bisect each other. So instead of putting 10 and trying putting, you know, from here to here, it's confusing. So I'm just going to cut that in half. I'm going to bisect it and call that 5, put it in the middle there, and call that 5. It's just easier for me to look at. Okay, my other diagonal is 24, and since that's also bisected, I'm going to put that in as 12 and 12. Okay, they want the perimeter of the rhombus. Ooh, perimeter. Perimeter is the distance around the outside. Okay, so I have to find this distance around the outside. Okay, this is actually a challenging one, so we're doing a hard one. Okay, well, what I know about the outside is that I know that a rhombus has 4 equal sides. So then I'm thinking, okay, well, if I can find one of these lengths, I'll know the other ones, right? Okay, so how am I going to do this? I start thinking of what am I going to know about a side length? How could I possibly know a side length? And then I might notice that that side is on a triangle. So let me just pick one. It doesn't matter which one. Let's look at this one right here, since I put those numbers on the outside. Okay, So looking at that triangle, I'm like, man, I sure wish this was a right triangle because I could do Pythagorean theorem for that, right? A squared plus b squared. Oh, wait, is it? Oh, I know, rhombus. A rhombus, the diagonals are perpendicular. It is a right triangle. Okay, if the diagonals are perpendicular, that means that they intersect at 90 degrees. Ah, and now I think I see the light. Okay, so remember with Pythagorean theorem, the side opposite the right angle is the hypotenuse, so that one's going to have to be C. The other two, A and B, it doesn't matter which is which. Okay, so you do your math here. Do I have a calculator? I do. I think that's 169. So I'm just going to do that all at one time. I'm literally just going to enter the whole thing, 5 squared plus 12 squared. Find out what that is, 169. Okay, that was all on the left, so I just did it all at once. All right, and then I need to undo the square. So the opposite of squaring is square rooting. And square root of 169 is 13. Okay, now be careful. Am I done? What have I found? I found the length of DC. I found that that is no longer an unknown, that is 13. But I was asked for the perimeter, so I'm not done. So if this is 13, because a rhombus has 4 equal sides, this is 13, this is 13, and this is 13. And the perimeter is defined as the distance around the outside. And we're talking about a rhombus, so just the distance around that 4-sided figure. So 13 plus 13 plus 13, I don't remember how many times I just said it, but 4 times. Or, because it's all the same, I could use multiplication here, 52, okay? 13 plus 13 plus 13 plus 13. Perimeter is the distance around the outside. It's going to give you the same answer either way. Okay, so the perimeter is 52, okay?